Hello everyone. So in last video we have discussed about electric field for some charge loop. So uh, today we can discuss about electric flux. What do you mean by electric flux? Okay. So number of field lines passing through some area. These are field lines passing through area. Let's say these are electric field lines passing through some area. Okay, so a flux is simple. Electric flux phi is E dot A. Phi electric field intensity, electric field strength into area. Okay, in integration from also we can write it, and here dot product is there. Okay, so in integration form it will be integration of dA is A, so we can write like this: E integration dA. So integration to the front, integration E dot product is there, dot dA. You can write that integration E dA cos theta. Okay, E dA cos the integration of dA, so E dot A, E dot A dot product E A cos theta, same thing. Okay, so this theta means electric field lines are passing in this direction, and this area, okay, this area facing in this direction. So area vector direction is, in which direction it is facing? In this direction. So area vector is perpendicular to the face. So this is the face, this is the face, this is, so perpendicular to the face means in this direction. So area vector is also in this direction, in cap area vector, and electric field is in this direction. So electric field and area vector angle, electric field and area vector angle 0 degree, same direction. For this face perpendicular to the face, so in this direction, so area vector for this side in this direction, but electric field is in this direction, so angle is 180 degree. So this theta will be 180 degree for this face, and for this face area vector and electric field will be 0 degree. Okay, so you have to understand this angle between electric field and area vector, this theta. So flux, electric flux, how much electric field lines passing through the area. That means if theta will be changed, then electric field lines will decrease or increase through the area, then electric flux will be also changed. Means in this direction, electric field lines are in this direction. So here all electric field lines are passing through the area, but here some electric field lines are passing. Okay, so flux will be less because angle is changed. Okay, and this area is facing in this direction. So this is the area vector, this is electric field, this is theta, whether it is 30, 40, whatever it is. So electric flux means field lines passing through area. Okay, so this is a basic thing. Actually what we want to do today, so we will discuss about Gauss law. Okay, so before that, just a little reminder to electric flux. Okay, so phi is equal to integration E dA. So you can remember this term, phi equal to E dA. So what do you mean by Gauss law? What is its statement? What do you mean by Gauss law? Total electric flux in a closed loop is 1 by epsilon times charge enclosed in the surface. Okay, so suppose the charge is Q, so flux total flux is 1 by epsilon times charge enclosed. Let's say charge q, so q by epsilon naught. Okay. And just we got integration E dot dA. So we can wrap up with this formula, phi equal to this much. So from these two terms, integration E dA equal to q by epsilon naught. This is the formula with which we can find electric field for some distributed charge objects. Okay, so integration in a closed loop E dA is equal to q by epsilon naught. Okay, according to, so what it means, actually you understand this formula, then it's easy. So right term 1 by epsilon is constant. Okay, permittivity. Q is charge enclosed in the Gaussian surface. What do you mean by Gaussian surface? Gaussian surface is an imaginary surface to enclose the charge only. That's it. How much amount of charge is there? You have to just enclose the charge. That's it. Okay. So total charge is Q. So this is the charge enclosed in the Gaussian surface. That means total charge is 4Q. And here it is written Q. That means out of 4Q charge, only Q charge is inside the Gaussian surface and 3Q charge is outside the Gaussian surface. So what we need? Only that charge which is inside the Gaussian surface, that much. Okay. So right term represents, this is constant. So this is charge, you can write it. Okay. Charge enclosed in the Gaussian surface, you write it. So from left term, what is the information about? So this is E electric field and integration of dA. Integration of dA, A. Integration of A. Sorry, integration of dA means A. What is the area? Gaussian surface area. Okay, that is. Okay, that much only. So left term represents Gaussian surface area. Right term represents total charge enclosed. Okay. So this much only. So using this formula, we can find out electric field due to a charged wire. Okay. Previously we found the electric field for charged wire. Okay. Using Coulomb's law. But here we can find electric field using Gauss law. Okay. So electric field due to charged wire. So at this point we want to find out electric field. So what we want to, this is r distance, let's say r distance. So first what we have to do, left term represents Gaussian surface. So you have to make a Gaussian surface which encloses all the charges. Suppose a charged wire is there. At this point I want to find out electric field. So just cover the charge surface. Okay, so this is the linear charge distribution So to cover, to enclose this distributed charge, we need a cylinder. That's it. So Gaussian surface will be a cylinder. Done. So Gaussian surface in this case is a cylinder. Just write the formula. Integration E dA equal to q by epsilon. This q is charge enclosed in the Gaussian surface. Okay, and this is information about the Gaussian area of the Gaussian surface, and we know the area of the Gaussian surface. So total area, this area A1, this area A2, this area A3. So E dot integration of dA A1 plus E A2 dot product is there, E A3 equal to Q by epsilon naught. Okay, so the this area is facing outward, so area vector is in this direction, but this is a charged wire, so electric field lines are away in this direction, electric field lines, so E are coming out. Okay, so angle between electric field line and area vector to the A1 surface is 90. In this direction also, this is facing down, so area vector downward, electric field lines are perpendicular to the area vector. So this is 0 as theta is 90 degree. This is also 0, theta is 90 degree. Okay, so I can write 0 direct. You write as theta is 90 degree, so this is 0. But in this case, this is a cylinder. Okay, this is a cylinder. So at each point like this is a cylinder. At each point it is along the direction of electric field line. At this point it is facing in this direction. Okay, so at this point electric field is also at the same direction. At this point electric field is in this direction and it is facing in this along the direction of electric field, so 0 degree angle. So for this surface, this A2, area vector and electric field are same direction, so cos 0 1. Okay, so only this term will be there. So E into A2 is 2 pi r into L length, let's say length is L, Q by epsilon naught. That's it. So E is equal to Q means lambda L by 2 pi L epsilon naught. So lambda by, so this is electric field due to charged wire, right? Thank you very much.